Welcome to Easy Math, making math easy. We've been looking into trigonometry for quite some time now. So we've come towards the fag end of the session. So we are going to look into the most important topic, that's heights and distances, the application-based problems of trigonometry. Okay, so the next couple of videos will be on that. So we will look into it at length and understand that. And it's one of the easiest concepts, trust me, and a very, very interesting one. Without any further delay, let's move on to the session. Okay. So we are going to start heights and distances based problems. The first and foremost thing, very, very important in such problems, is that you need to read the problem, understand, and convert it into the figure. Okay. So drawing the figure plays a very, very, very important role in this. Once the figure is done, trust me, half the problem is solved. After drawing the figure, next comes how to find the unknown. So now, once you draw the figure, you need to label it properly. You need to mark whatever is given in the question in the relevant place very, very clearly so that you know what is asked for and what is the unknown. Now, so in trigonometry, mostly we deal with right angle triangle, right? See, so the unknown could be either the altitude, the height of the triangle, or the base of the triangle, or the hypotenuse of the triangle. You need to spot out what is to be found out, and most of the time the angle would be given and one of these sides would be given. So you all know very well how to find the unknown. So once the figure is drawn, it becomes very, very easy. Basically, we can categorize the heights and distances problems into few categories. Okay, so in the next couple of sessions, we are going to look into few questions that would help you to solve whatever comes your way. Okay, so we'll be solving different type of questions. So go through it and then practice it well and keep going through the video and try solving as many sums as possible. Trust me, you will be able to solve any type of sum that comes under this topic. Okay, let's move on to our first question. So the question says, a girl standing on the ground finds a bird flying at a distance of 120 meters from her at an elevation of 30 degrees. A man standing on the top of 20-meter high building finds the angle of elevation of the same bird to be 45 degrees. The girl and the man are on the opposite sides of the bird. Find the distance of the bird from the map. As I told you, let's first understand how to draw the figure. Okay. So now see, a girl standing on the ground. So let's suppose there is a girl standing here. Okay. So this is the ground level. Okay. This is the ground level. Imagine, and there's a girl standing here. Okay. The ground level is here. Okay. And she's standing here. On the ground finds a bird flying at a distance of 120 meters from her. So there is a bird flying here. Okay, so this is going to be the bird, and let's suppose that A is the position of the girl. Okay, at an elevation of 30 degrees. So what do you mean by elevation? So when you look up, okay, the angle that you make with the horizontal, okay, here in this case it's the ground, okay, so the angle that you make, okay, the line of sight, okay, the angle that your line of sight makes, right, with the horizontal, okay, that's the ground level, is called as the angle of elevation, and that is given to be 30 degrees. Okay, so it's always drawn with respect to the horizontal, okay, either the ground level or the line of sight, okay, the horizon, that's what you call. Okay, when you look straight, the path taken by your eyesight, okay, so that's called as your horizon. Okay, so that is going to be the horizontal line. With that, the angle of elevation and the angle of depression are made. So when the angle of depression comes, I will tell you how you'll have to mark it. Okay, so as of now, this is your angle 30, And okay, so the angle of elevation is 30 from the girl. Okay, now a man standing on top of a 20-meter high building finds the angle of elevation of the same bird to be 45 degrees. Now, where is the building going to be? Let's read the question. The girl and the man are on the opposite sides of the bird. So the bird is here, so the man is going to stand on the other side. Okay, so the building is somewhere here. Okay, and that building is 20-meter high. And the man is standing on top of it, and from there the angle of elevation. Okay, so he's looking up at the bird. Now, how to mark the angle of elevation? So since he stands here, his line of sight, okay, the horizontal, when he looks straight, the line is going to be this line. That's going to be parallel to the ground. Okay, so this is going to be parallel to the ground, and the angle of elevation is marked with respect to that. So that is going to be 45 degrees. Okay, the girl and the man are on the opposite sides of the bird. Find the distance of the bird from the man. So you're supposed to find this distance of the bird from the man. So let's quickly mark the figure that we have. So we have already marked B there. So let this be C and let this be D. The bird was said to be flying at a distance of 120 meter from the girl. Okay, so the this distance of the bird from the girl is going to be 120 meters. Okay. Now let's first plot out the right angle triangles that we have. So triangle 1 is going to be ABE, and then triangle 2 is going to be BFC. Okay, so this is one triangle, this is one triangle. Let's quickly try to find the unknown. See ways to find this one. Okay, so now you have something with you. Correct, you have something with you. That's nothing but 30 degrees. Angle BAE is 30 degrees. And you have one of the sides also of this triangle ABE. Okay, with that, let's see if we can find something else that will be useful for us to find BC. Okay, so if you see this side, okay, a part of this side, the part of the perpendicular, the opposite side of 30 degrees is a part of this triangle BFC. If we find out the perpendicular, it might be of some use, right? So let's try to find that out. So we have angle A to be 30 degrees and the hypotenuse of the triangle to be 120 meters, okay, from this triangle ABE. So what I'm going to do is I want to find the opposite BE, okay, the opposite side BE. So what is the ratio, trigonometric ratio that involves the opposite and the hypotenuse? That's nothing but your sine. Okay, so sine of 30 degrees is going to be the opposite, that is BE divided by AB, that's 120 degrees. Okay, I mean 120 meters. Now, you know what is sine 30. I've already told you, every time you solve trigonometry based problems, please make the table that I've taught you in length as to how to make it and keep it on your paper so that any time you can refer to it. Okay. So now if you see, sine 30 is going to be 1 by 2. Okay, so sine 30, I'm going to replace 1 by 2 there. You can check the tables once. So is equal to BE by 120. So now from this you will be able to find BE. We are taking this 120 to the other side. Okay, 120 getting divided here goes as half into 120. That's 120 by 2. That's nothing but 60 meters. So we have found out B. Now how is it of any use to me? Only BF is a part of this triangle where my unknown is there, right? But I have BE now. Now how to find BF? If you observe here, there is a rectangle, correct? So there is a rectangle here. This one, that is nothing but CDEF. This is a rectangle, right? So you know in a rectangle, the opposite sides are equal. So now, if this is 20 meters, then I can definitely write that FE is also 20 meters because basically FCDE makes a rectangle, correct? And you know the complete measure of BE. From that, can you find BF? Of course, yes. So your BF BF is going to be BE minus FE. So your BE has been found out to be 60 minus FE is found out to be 20. So your BF is 40 meters. So I have found out this BF, that's nothing but 40 meters. As and when you find out the unknown values, keep marking it on the figure so that it gives you a lot of understanding, and it will also make you easy to find the unknown. Now see, now I'm supposed to find this one. Let me take it as X. Okay, the BC as X. I'm going to find out BC. So now what triangle should I take? I should take the triangle BF. In BFC, I know this angle C is equal to 45 degrees. And the measure opposite to that, the measure of the side opposite to that I have. And I'm supposed to find the hypotenuse of that particular triangle. So what is the trigonometric ratios that involve, ratio that involves the opposite of the hypotenuse? Then again, it's going to be sine. So I have sine 45 is equal to BF by BC. Okay, my sine 45 value is 1 by root 2. Again, I suggest that you check the table for the values. Okay, so BF is going to be 40 by BC is going to be X. So this is what I have. Let me erase and make some space for me to solve this further. Okay, let me place it here. Now I have just this equation. I'm going to place it here. I have 1 by root 2 is equal to 40 by X. I'm supposed to find the value of X. So from here, what do I know? I take X to the other side. X is equal to, I'm bringing root 2 to this side. So it's 40 root 2. Okay, so the root 2 value, you have the root, tables that will be provided for you for the examination. You can go and check it there. But what I suggest is root 2, root 3 values and root 5 values. Root 2, root 3, root 5. If you know it by heart, it will be very, very useful for you. So your root 2 is 1.414. So I'm going to multiply 40 by 1.414. And what do I get? So when I check, I get around 56.56 meters. So this is my unknown. So here, in sums like this, you will be getting certs, okay? And not only that, you will be having, you'll have to deal with decimal numbers. You need to be very, very careful when you deal with it. Okay, avoid making careless mistakes like calculation errors. And then when you deal with irrational numbers, know your rules properly, how to operate irrational numbers. Okay, so know your rules properly and then operate, because at times you might go wrong in that. Okay, so know your rules properly and then do it, and avoid making careless mistakes. So now we have found out the value of X, that is BC. That's found to be 56.56 meters. Okay, it's going to be in meters because the other measures are also given in meters. So this is also going to be in meters. So now what is the last and the final thing that you have to do? You'll have to write that, therefore, the distance of the bird from the man is 56.56 meters. This is very, very important. Okay, the figure is important wherein you are marking the X. So unless and until you mark it and you just use it like that, it is not going to make any sense. Okay, the examiner will not know what is X. Okay, so your figure has to be very much explanatory. It has to have all the details that are given in the question. Once the figure is made, it will be very, very useful for you to solve for the unknown. Okay, spot out the right angle triangles. Find something that is relevant to the triangle that contains the unknown, and then go about solving it. And then don't forget to give the final answer statement. And don't forget to give your rough work on the same page where you write the question. Okay, so these are the few tips that you need to remember when you solve any sort of problems in mathematics during the examination. So let's quickly move on to our next question. So in the previous question, we saw the angle of elevation, how to mark it. Okay. So in this, we are going to deal with both angle of elevation and angle of depression, so that you will be able to understand how to mark the angle of depression also. Number one, and then number two, we found the hypotenuse there. Now let's see what we are going to find out on this. Okay. Now understand the question properly. There is a building. Okay, from the top of a building, 30-meter high. So there's a building that's 30-meter high. The angle of elevation of the top of a monument is 45 degrees and the angle of depression of its foot is 15 degrees. Find the height of the monument. Now there is a building. Okay, so we know that there is a building. Okay, and the building's height is 30 meters. So let's quickly draw that. Now, there's another one, that's the monument. Okay, so that also will be represented using a straight vertical line. Now, should the monument be taller than the building or shorter than the building? So now we need to understand. Read the question. It says the angle of elevation of the top of a monument. So what is angle of elevation? When you look up, then that's called as angle of elevation. So you're going to look up at the monument. So the monument is going to be taller than the building. From the top of the building, you're looking up, okay, at the top of the monument. So obviously the monument is of greater height than the building. Okay, not only that, and the angle of depression of its foot. So you're going to look down at its foot also. Okay, at its foot also. Now, so this is going to be your monument. And then this is your building. Okay, so you're going to look up at the top of the monument from the top of the building and then look down at the bottom of the monument from the top of the building. So only because of that you get an angle of depression. When you look down, when you bend from the direct horizontal level, then it forms the angle of depression. Now, how to mark these angles? Where should I mark the 30 and the 45? When I look up, okay, so that makes the angle of elevation. That is given to be 45 degrees. I'm sorry, the angle of elevation of the top of the monument is 45 degrees. So when I look up at the top, I get 45 degrees. So I should always mark it with the horizontal line of sight. When you look straight, okay, how does your line of sight go? That's a horizontal line that's always parallel to the ground level. So with that, I will mark the angle of elevation that's given to me 45 degrees. Now, I'm going to look down. Okay, the angle of depression of its foot is 15 degrees. So how do I mark it now? When I look down, okay, from the horizontal, again the line of sight, when I look straight from that line, okay, from this line, I'll have to mark the angle of depression, that is 15 degrees. Okay, so now let's see how to find the height of the monument. We have marked all that we have in this. So let's label the triangles also, the figure completely, all the corner points, to name it. So you have A, B, C, D, E. Okay, so this is our figure. Now let's quickly spot out the right triangles, and also equal sides we can, label it. Now EDBC is a rectangle. So this ED will be equal to BC. So this is going to be 30 meters for me. Now I need to find the complete height of the monument. I have a part of the monument. Okay, the height of the part of the height of the monument, I know it's 30 meter. So it's enough if I find this AB. Correct? If it's enough if I find this AB. Now let me see if I have any other right triangle with me. Oh, okay, with which I'll be able to find this X out. Now, what are the right triangles that I have? I have ABE, triangle ABE. Okay, I have triangle EBC and I have triangle ECD. Now, I always suggest that the angle of depression is always converted into angle of elevation. Okay, that is always advisable, because in this question it doesn't matter, but most of the questions you will end up into trouble if you don't convert it. So always make it a practice to convert the angle of depression to angle of elevation. Okay, so now when I look down from E, okay, the same angle will be formed when I look up from C, okay, from the end point up at E. Okay, so from E to C, whatever angle is formed, the same angle will be formed from C to E. Okay, so the angle of depression will be equal to the angle of elevation because these two lines are parallel and this acts as a transversal. These are alternate angles. Okay, so I have converted the angle of elevation, I mean depression, into angle of elevation. Okay, now so let me see what are the angles that I have, the right triangles related to that. So I'm going to have this triangle ADE and triangle ECD. Okay, so let me just remove this EBC. Now let me see what best I can do. If you see this triangle ECD, I have the opposite. I have the angle here, but I don't have the hypotenuse, either the hypotenuse or the base. Now observe, if I find the hypotenuse, will it be useful? Or if I find the base, it is going to be useful. See, for me, I feel the base is better. If I find this one out, I can easily equate this to BE also. So that I get one measure of this triangle ABE. Okay, so it makes okay, let me name it Y because I've already marked it as X there. So let me name it as Y. So this makes it easy for me to find out the unknown X, correct? So now I have this triangle, I need to find the Y. So how am I going to find? I can use the opposite by adjacent, that's nothing but tan 15. Tan 15 is equal to ED by DC. That is 30 by Y. Okay, so if I have two measures with me, an angle and one of the measures, I'll be able to find out the measure of the other sides easily. Okay, so that's the trick. Now, you can ask me, ma'am, 15 degrees is not a standard angle. Now, how am I going to find it? My table will not give me this, the table that I make it. Right? That will not give me this. Now, how to find the value of tan 15? So, you are given the tables at the back of your book. You will be provided during the examination. Okay, the tables that has tan, sine, cos of all the angles. That's between 0 and 90. Okay, so you can use that to find the value of tan 15. If you look into the table, you will observe that tan 15 is nothing but 0.2679. Okay, so that is equal to 30 by Y. So now how to find Y out? Y is equal to 30 by 0.2679. Now these are, you need to be very, very careful when you operate on such numbers because you're going to divide by a decimal number. So that's not easy. So now what are you supposed to do? You need to eliminate the decimal onto the denominator. Whenever the denominator is a decimal number, try to eliminate the decimal point from that. So how do you do that? I can see that there are 4 digits after the decimal point. So I'm going to multiply by 10,000. Okay, 1 followed by 40, both the numerator and the denominator. Okay, so whatever I do to the numerator, I have to do to the denominator, right? Those are only called as equivalent fractions. So now what do I get? Okay, let me write it here. Let me erase the question now since my figure has been formed. I don't need the question anyways. Now let me erase the question out. Okay, so this is my A. Okay, so this is going to be Y is equal to 3 followed by 5 zeros. So 3 lakh divided by 2679. Now this you do by long division. Okay, so practice such things so that it is easy for you to do it during the examination. Please don't sit on this for a long time. You need to be swift in your calculations. Okay, so you get around 101.98 meters is going to be your Y. Okay, so you found out the Y. Is it easy for me to find out X now? So this is 111.98. This is also 111.98. Now I have to find the opposite of 45 given the adjacent of 45. So what am I going to use? I'm going to use tan 45. Opposite by adjacent, that is x by 190, 101.98. Okay, so tan 45 valued. 45 is a standard angle. So tan 45 is 1. So 1 is equal to x by 101.98. So which implies x is also equal to 101.98 meters. So this is the height of AB. Now is that the height of the monument? Of course not. It's just a part of the monument. So you need to look into the figure and then write the correct answer. So I'm supposed to find AC. That gives me the height of the monument. So AC is nothing but AB plus BC. So that is equal to 101.98 plus 30. So that's nothing but, because this is 30 meters, right? I have marked it here. Look at the figure. So I have 148.98 meters to be the height of the monument. Okay, so this is my answer. So am I done with all my steps? Of course not. I need to write the final answer statement. Please don't forget that. Therefore, the height of the monument is 148.98 meters. Okay, so in this we saw how to mark the angle of depression and then angle of elevation, and then how to convert the angle of depression to angle of elevation. Okay, so always convert it. Okay, and then we also saw how to find the height. Okay, that's the length of the perpendicular here. So that's what we found out. In the previous question, we found out how to find the length of the hypotenuse. Here we are finding the height or the length of the perpendicular. Okay, so the trick lies in making the figure. So once you make the figure, everything becomes easy. So I suggest you to kindly look into variety of problems and make the figures first, and then start finding the unknown, labeling the figure and marking the entries that you know. The values that you know is very, very important. And then you put question mark as to wherever you don't know and try to find the relevant measures and towards divert the sum towards finding the unknown. Okay. So it's going to be very, very easy and interesting. Trust me. Before I end the video, I would like to tell you all that there was a mistake in the solution that we discussed now. The final calculation of 111.98 plus 30 went wrong. It is 141.98 and it's not 148.98. Sorry, children, it was a calculation error. So it's 141.98 meters. Okay, kindly avoid making such careless mistakes. So the final answer statement would be, therefore the height of the monument. Okay, so the height of the monument equal to 141.98 meters. So trust me, once you start solving problems based on heights and distances, it gives you a lot of satisfaction. Just try to find the unknown and enjoy that. Okay, so have some that gives you a lot of confidence also. So in the next session, we'll be solving 2 other problems of different types. After that, I feel you will all be able to ace this particular topic. Yes, I hope my session was interesting. With that, we have come to the end of the session. So keep practicing. As I always tell you, practice makes a man perfect. Okay, practice, and practice is the mantra for success. Okay, so it's a very proven way wherein it will lead you to definite success as far as at least mathematics is concerned. Okay, so what I suggest is do practice more of heights and distances problems. And if you have any doubts, feel free to put it on the comment box. I'll definitely address to it in the upcoming session. Thank you all. See you.